Introduction. What is the difference between non-multiprogramming and multiprogramming? We will talk about what is the non-multiprogramming in a single processor. In non-multiprogramming in a single processor, the state CPU is play to implementation process 1. When go to implementation process 2, the state CPU is idled because the process 2 dependent of output from another function. Later the state CPU is play to complete the rest of the processes. And we will talk about what is the multiprogramming in a single processor. In multiprogramming in a single processor, the state CPU is play to implementation process 1. When go to implementation process 2, the state CPU is switched to implementation process 3. Because the process 2 dependent of output from another function. Later the CPU is go back to process 2 to implementation it, and complete the rest of the processes. The most important aspects of an OS is the ability to run multiple process multiprogramming, to increase CPU utilization, also to keep users satisfied. Notes. 1. In old computers it was used a non-multiprogrammed system, the CPU would sit idle. 2. In modern computers that use a multiprogramming system, the operating system simply switches to, and executes, another process. If you study operation system, or the computer operating system is mentioned, you often hear the word multitasking, which makes you ask,
what is multitasking?
Multitasking, in an operating system, is allowing a user to perform more than one computer task at a time, such as operations of applications. The operating system with multitasking is able to keep track of where you are in these tasks and go from one to the other without losing information. Let's go to the computer lab. Microsoft Windows 2000, IBM's OS/390, and Linux are examples of operating systems that can do multitasking. Almost all of today's operating systems can. When you open your web browser and then open Word at the same time, you are causing the operating system to do multitasking. But be careful. Being able to do multitasking doesn't mean that an unlimited number of tasks can be juggled at the same time. Each task consumes system storage and other resources. As more tasks are started, the system may slow down or begin to run out of shared storage.
Hey Jack, how about we hang out tonight?
Sorry, I can't. Because I'm busy. I have a lot of tasks to get done. I have to act like a scheduler.
Excuse me? What is the scheduler?
The scheduler is like a policeman, responsible for organizing the process cycle by deciding which process to run and which process to wait for the resource to finish.
It sounds great. I would like to know more about the scheduler and when does the scheduler start making a decision?
The scheduler begins to take a decision in these cases: switch from running to waiting state, switch from running to ready state, switching from waiting to ready state, and terminate.
The only problem I have is that I don't know what scheduler to choose.
Well, Tom, I will tell you right now. But first, let's have a drink.
Okay, Jack, it is a good idea. The coffee tastes good. Now, Jack, can you answer my question?
Of course, Tom. There are 5 algorithms. And the first one is first come, first served. And it is non-preemptive. It is characterized by the process that arrived at first takes the service until it is waiting or terminate. But its problem is that the convoy effect, which means that the current process is waiting for the large process to terminate firstly. The second algorithm is shortest first job, and here, the process that is smallest in length will take the CPU firstly. This algorithm is less in the average time. The third algorithm is round robin, and it is like first come first served, but it is preemptive, and every process has a quantum time. The fourth algorithm is priority scheduling, and this gives priority number for each process. The one with the highest priority number is the one that goes to the CPU. The fifth algorithm is multi-level feedback queue, which means that the process can move between other queues, because the multi-level feedback scheduler knows every queue algorithm. and this algorithm is appear to be the most general but also the most complex because it needs many decisions.
Okay, and thank you, Jack, for telling me all this information.
You are welcome, my friend.
Multiprocessor systems have many processors that can perform different tasks. This can be done in symmetric or asymmetric multiprocessing. So I and my friend Yasmin will explain the difference between them. Hello Yasmin.
Hello Mohammed.
In asymmetric multiprocessing, the processors are not treated equally. Tasks of the operating system are done by master processor.
All processors communicate with another processor by a shared memory. In symmetric multiprocessing system, process is taken from ready queue.
No communication between processors as they are controlled by the master processor. In asymmetric multiprocessing, process or master slave. In symmetric multiprocessing system, process is taken from ready queue. Asymmetric multiprocessing systems are cheaper. Asymmetric multiprocessing systems are easier to design.
Symmetric multiprocessing systems are costlier. Asymmetric multiprocessing